To estimate the bleaching powder required in the drinking water or in pools, you need to estimate it. You can estimate it using the design sheet, in which you can enter the volume of the water. If it is 20,000 liters and you have a chlorine dose, which is chlorine demand plus FRC of, for example, 0.7 mg per liter, and the chlorine content in bleaching powder as 25%, you need to add 56 grams of bleaching powder for a total time of 30 minutes to 1 hour as the minimum contact time to kill all the pathogens in the drinking water. So the bleaching powder is estimated. If it is for 50,000 liters and the chlorine dose is 0.6 mg per liter and the chlorine content in the bleaching powder is 20%, then the bleaching powder required is 150 grams. And in other way also, you can design or calculate the requirement of bleaching powder, as the bleaching powder chlorine is highly dependent on the pH. So this is another design example in which the pH temperature is also considered in the design. As you can see that the volume of water and the chlorine content is taken as 25%, and if the chlorine dose is kept at 0.8 mg per liter, the chlorine dose is to be determined or to be taken from standard doses 0.8 at 20 degrees centigrade of temperature and at a pH of 7, and we need the chlorine dose at a, for example, at a temperature of 25 degrees centigrade, and for a pH of very high pH of 9, we need the bleaching powder as 286 kilograms and a minimum contact time as calculated as 8 minutes, but usually it needs to be taken in the higher range from 30 to 60 minutes in the practical application in field. So the pH has high effect on the bleaching powder required dose. If, for example, keeping the pH of water as 7, then from 286 kilograms of bleaching powder, the bleaching powder requirement came down up to 13 kilograms only. So the pH is a very important factor for the estimation of bleaching powder. This is because the bleaching powder dissociates and becomes HOCl and OCl, which is dependent on the pH of water, but the HOCl is a very powerful oxidizing agent than OCl. So at the lower pH range the HOCl is more, so the action of killing or disinfecting and oxidizing the impurities is higher at lower pH, and at higher pH there is more concentration of OCl, so the disinfecting action will be less, hence more bleaching powder will be required. So in these two ways, first is without considering the pH and the temperature, you just know the chlorine content in the bleaching powder, the chlorine dose and the volume of water. You get the total bleaching powder to be kept in the water for disinfecting and also to keep a free residual chlorine in the water for further disinfection. And in second way, if you know the chlorine dose at temperature and pH and you require the chlorine dose to be kept at other temperature and for other pH of water, this is a relatively complex method than from the first method, but from this sheet you can also design or estimate the bleaching powder with pH and temperature. Also you get a complete chart which have a bleaching powder, the chlorine dose, pH and temperature. It means that with temperature and pH the bleaching powder is also known from this chart. Also the commercial bleaching powder does not contain only calcium hypochlorite, but it is a mixture of calcium hypochlorite, calcium chloride and slaked lime. Hence the bleaching powder available chlorine content only lies at a maximum of 30 to 35% when freshly made. However, it goes on degrading over time. The actual available chlorine in the bleaching powder goes on decreasing. So the freshly made bleaching powder, the available chlorine in the bleaching powder should be checked in the lab with the iodometric titration method. How to estimate the chlorine demand in bleaching powder? In simple, It can be done in 6 steps as given. Also, there are factors that affect the disinfection with chlorine, and the pH of the water is very important in the disinfection process. So from these two Excel sheets, Excel A and Excel B, you can design or calculate the bleaching powder that is required to be put in the water. I have kept a link of this article in the description of this video and also pinned in the first comment of this video, which you can check.